All right, in this video I'm still looking at the graph of a first derivative and trying to interpret what I can about the original function. In this video, I'm going to be trying to sketch the original function based on the graph of the derivative. So I've already done a little bit of graph analysis, and now I need to see if I can draw the original function just looking at what I know about the derivative. So I have my x-axis that I'm going to try to keep pretty much the same, except I'm really bad at spacing apparently. So 1, 2, 3, 4, 5, 6. I only care about my function up until 6. And -1, -2, -3, -4, -5, and -6. Again, when I have an original function, I can find y values. But when I don't have my original equation or my original graph, I have no idea what my y values are. So in this case, I do have one specific thing. I'm going to say, let's go ahead and assume that f of 0 equals 0. Let's just go ahead and say that that's true. So let's plot that point. F of 0 equals 0. The height of the rest of this isn't going to really matter, but the x values are really important because the x values aren't going to change. So if I wanted to draw the original, first I'm going to look at everything having to do with that first derivative. It's going to tell me increasing, decreasing, minimums, maximums, and critical values, and that all comes just from looking at the positive and negative of my derivative. Is it up? Is it down? Does it go from up to down? Does it go from down to up? Is it right on the line in between them? So let's go ahead and start with those critical values right on the line. When we're solving this with equations, that's the first thing we do. We get the first derivative, we set it equal to 0, and we find those critical values. So we have our first derivative. This is where it's equal to 0. So let's go ahead and get those critical values plotted on here. We know critical values are going to be places where the slope is 0. So I'm just going to do a dot above the x-axis just to say I have a critical value there, but I don't know if it's a minimum or a maximum until I start to analyze it. So I'm just going to kind of signify that my critical values happen in these places. So I have a critical value at -6 right here. I have a critical value at -2 at that x point right there. I don't know if it's up here, but I'm just signifying that this is the x place where this happens, the x value. I have a critical point at 0. I'm going to put one right up here. I have another one at 2. Another one at 4. Now these could be minimums or maximums, or they could just be places where my slope is 0 and my function doesn't change. So in order to determine that, let's go ahead and figure out when we're above those critical values. That tells us when we're increasing. All right, so we'll start with that. Where is this function increasing? So I know that this is a point. I'm going to start here. Between 0 and 2, I know that I am above the x-axis. I know that my first derivative is positive, so I know I have a positive slope. I'm going to go up this way, right? Over here on this side, I knew that between -6 and -2, I am also increasing. That's a long way to increase. So I don't know where to start that yet. I think what we'll do is we'll start from this point. So we have this 0 to 2. We know we're increasing. Let's go ahead and do what we know is happening over here. So we were looking for those positive values to tell us when we're increasing. I'm going to look at the negative values to tell me when I'm decreasing as well. So I know I'm decreasing when this y value over here is negative. So between 2 and 4, my y values are negative. So between 2 and 4, I'm going to be decreasing. Looks like I could come right back down again. I also know that I'm decreasing between -2 and 0 because I have all negative y values there. So between -2 and 0, I'm actually decreasing going this direction, right? From left to right, I'm going downhill. So now that helps me over here. From -6 to 2, I knew I was going up. I just didn't know where to meet it. So I could come from this way. I could come from this way. I could come very gradually, almost in a straight line. I really don't know what those y values are, remember? But I'm going to go ahead and say it's a little steeper. I'm going to draw it with a steeper angle just so that I can exaggerate it for the camera. So I know I'm increasing until there. Then there's one more place I haven't talked about yet. It's right over here from 4 to 6. I am above the x-axis, so we now know that means that I'm increasing. So between 4 and 6, I'm going uphill again. Now, I don't really know how this is happening. I know it is happening, but I don't know how. And we can figure out how we're increasing by looking at the rate of change of our increase, which comes from our second derivative, that comes from our concavity. Am I increasing really quickly at first and then not so fast? Or am I increasing really slowly and then much faster? Or am I just increasing at a steady rate? I don't know, right? So let's look at the concavity, which we can find from our first derivative by looking at the first derivative's slope. Remember, when we're looking for something that has to do with the second derivative, like concavity, we're looking at the slope of our original function. So I'm going to say second derivative is slope. I'm going to go back over here and remind you that first derivative is just y values. So if I'm looking for the concavity of how this changes, I'm going to start from left to right and go over what I've got here. So I'm going to start over here at -6. If my first derivative, remember I'm looking at the slope, if my first derivative has a positive slope, that means I'm concave up. So I have a positive slope all the way from -6 to -4. So between -6 and -4, I'm concave up. Concave up looks like a cup. There we go. Concave up that whole time. Then from -4 to -1, I have a negative slope, which means my second derivative is negative. So I'm concave down. So between -4 and -1, this whole time, I'm concave down. We can kind of see that that could be very well true because I have this maximum here, right? So it's going to curve real nice like this, concave down like a frown. There we go. And now we can see I haven't drawn it exactly right, spot on like that. And this should be a little steeper on this side. Sorry about that. Here we go. That means that I've got this concavity here. So I have that maximum that I was looking for. So this point right here is a maximum, concave down until there. Now between -1 and +1, my derivative graph is increasing. I have a positive slope. So since I have a positive slope, I have a positive second derivative. So I'm concave up between -1 and 1. So from here to here, I'm concave up. We do have to make sure that it goes through our point 0, 0. So I'm going to draw it a little higher here. There we go. All right. So here we are concave up like a cup. Then I have a negative slope again from 1 to 3. So I'm concave down from 1 to 3. There we go. 1 to 3. And then from 3 to 6, that whole time, I'm concave up. So from 3 to 6, this whole time, I'm going to be up like a cup. And we can see all those critical values that we put into place before. Those are all going to correspond with either minimums, maximums, or sometimes places where the slope is 0, but we don't change from increasing to decreasing, which on this graph doesn't happen, but it could. It could very well go to a 0 slope and then continue to increase or something like that. So by looking just at the y values and then just at the slope, we're able to graph a really nice representation of our original function. Okay? So that's the end of the videos on interpreting graphs. We're going to move on to another subject in the next video.